Okay, we're starting Unit 2 now, and as I mentioned in the lectures in Unit 1, we're kind of, the first 3 units are breaking the procedure for the urinalysis down into a few different sections. So Unit 1, we covered the physical properties or the physical examination of urine. In this unit, we are going to cover the chemical examination of urine, which covers all of the tests that are on the reagent strip for the urinalysis, and then in Unit 3 we're going to cover the microscopic. So there is a lot of information in this chapter, so I'm going to break it up into 3 different sections. This first lecture will be just kind of an introduction. The second part we'll start getting into some of the tests, and the third lecture will finish out those tests. Okay, so reagent strip testing is a rapid means for performing medically significant chemical analysis of urine. Those strips, the reagent strips, urinalysis strips, provide results for pH, protein, glucose, ketones, blood, bilirubin, urobilinogen, nitrite, leukocytes, and specific gravity. So those are all of the tests that are included on that reagent strip. So we're going to go through each one of those tests. These strips are made up of chemical impregnated absorbent pads that are attached to a plastic strip. A color producing chemical reaction takes place when the urine comes in contact with the pad, and each test on the reagent strip takes a different amount of time to react, and the color reactions are compared to a chart provided by the manufacturer or read by an automatic analyzer. They have single and multi-test strips are available, so most labs are going to perform those going to use the multi-test strips and provide results for all of the parameters that I mentioned just a minute ago. Some specialty labs, or maybe even in the emergency department, they may have just single test strips available. The 2 major manufacturers and types of strips are Multi-Sticks and ChemStrip, and there are some variations between the strips, so it's good to know the differences in sensitivity, specificity, and interfering substances for the brand that your lab uses. And your lab's going to use one or the other. They would not have both. There are color comparison charts that are supplied by the manufacturer that go with the brand that you're using to correspond to those color reactions. And there's several degrees of color changes that are shown on those charts, and those differences in the colors will correspond to semi-quantitative readings. So for instance, a particular color and the variations of the colors would correspond to a result of negative, trace, 1+, 2+, 3+, or 4+. And then some test results also correspond to a more quantitative value, which would be reported in milligrams per deciliter. And there's just a picture of some of that looks like a Multi-Sticks canister there. So what the canister looks like, the color chart that's on the outside of the bottle, and then the strips themselves. Okay, and here's just another example of the color chart that would come with a set of reagent strips, and it shows your test here. So the different tests that you're testing for on that reagent strip, and then the color reactions. And I know it's too small to tell from this slide, but the writing underneath each one of those color pads is the corresponding result. Okay, techniques for using your reagent strips. So you want to dip the strip briefly into a well-mixed specimen that's been allowed to come to room temperature if it has been refrigerated. You want to remove excess urine from the strip by wiping the strip along the container as the strip is removed from the specimen. So that doing that kind of wipe as you take the strip out of the specimen, that prevents what is known as run over. Then you want to blot the edge of the strip on an absorbent pad. So this also helps to prevent run over, but it can also cause what's called leaching, where the reagents leak out of the pad. So run over is when the reagents leak out of the pad, but they leak onto the next pad like beside it. And then leaching is just when those reagents come out of the pad. So if the reagents are no longer in the pad, then the result is not going to be accurate. You want to wait the specified amount of time for each test before interpreting the result, and each test does have a different amount of time. And for interpretation of the results, you want to compare the reaction on the reagent pad to the manufacturer's chart. You want to do this under good lighting and make sure to hold the strip horizontally when comparing the colors to the chart. There are some errors that can be caused by improper techniques, so you want to make sure that you're doing this properly. So red cells and white cells sink to the bottom of unmixed specimens. So they won't be detected if the specimen has not been mixed properly. And we talked about that in Unit 1, the different changes that can take place in a specimen that's been left to sit at room temperature or that's not mixed properly before you are evaluating it. Allowing the strip to remain in the urine for an extended period can cause the reagents to leach from the pads. Excess urine remaining on the strip after removing it from the specimen can cause runover between the chemicals on the adjacent pads, which can distort the colors. So that's why you want to make sure to blot the strip well on a paper towel or something absorbent, and hold the strip horizontally when you're comparing the strip to the manufacturer's color chart. If it's not blotted and if it's allowed to sit too long before running or reading the strip, this can also cause leaching. You want to be mindful of the time that each test takes for the reaction so that you're ready for the interpretation. So if you're reading results manually, you're kind of keeping your eye on the clock while you're also looking at the reagent, the colors, the results. The amount of time is manufacturer specific, so you also have to be mindful of different guidelines. Reagent strips and color charts from different manufacturers are not interchangeable. Good light source is essential for accurate interpretation of those color reactions. The strip needs to be held close to the color chart without actually being placed on the chart, and automated readers are not at the mercy of bad lighting or variations in interpretation between different personnel. So if you've got an automated reader, then a lot of these things you don't have to worry about. And then specimens that have been stored in the refrigerator must be allowed to come to room temperature before testing, because those enzymatic reactions that are occurring on the reagent strips are temperature dependent. Okay, next, and I got a little bit ahead on the slides, handling and storing of the reagent strips. So the strips have to be protected from deterioration that could be caused by moisture, volatile chemicals, heat, and light. So you want to remove the strips just prior to testing, and then the bottle should be tightly resealed as soon as you take that strip out. So you don't want to say, hey, I've got 5, or I've got to say you've got a urine that needs a urinalysis, but you're expecting another one to come from the ER in just a minute. So don't go ahead and take that reagent strip out and leave it sitting there while you're waiting on that next urine to come over. Just only take those strips out of the package right before you're ready to start the testing, and then reseal that bottle as soon as you've removed that strip. So strips are packaged in opaque bottles with a desiccant to protect them from light and moisture. And you want to store the strips at room temperature. So that room temperature is usually around 23 degrees Celsius, but definitely below 30 degrees. But you don't want to refrigerate them. And then strips should not be used past the expiration date. And visual examination should be done to make sure that the strips do not show any kind of deterioration or discoloration in the pads, even if they are still before the expiration date. Maybe they were exposed to something, you know, inadvertently and you weren't aware of it. But if you notice that those strips do not look right, you know, if they're discolored, even if they're within their expiration date, go ahead and get rid of them. And then you want to be careful not to touch the chemical pads. Okay, performing quality control of reagent strips. And I've mentioned previously in lectures for other classes, for every test that we perform in the lab, we have to ensure that the results that we're reporting are accurate. We do that by performing quality control. So positive and negative controls for our urine reagent strips have to be run at least once every 24 hours or when a new bottle of strips is opened. So if it's from a new lot number or a new shipment, we would have to perform QC, or if there is any kind of concern over the integrity of the strips. Controls have to be properly documented per your lab's protocol, and manufactured positive and negative controls are available. Results have to be within those manufacturer's guidelines for the results, and you have to be aware of the manufacturer's limitations and possible interfering substances. Distilled water cannot be used as a negative control because reactions are designed for urine ionic concentration. All negative control readings should be negative, and all positive control readings should agree with published control values by plus or minus 1 color block. So it's important to be aware of any manufacturer stated limitations and interfering substances. And then finally, chemical readings should be related to one another and to physical and microscopic readings. So all of your, you know, the physical examination, the chemical results, and the microscopic results, all of those should kind of work together to paint a picture. So if those three elements of the urinalysis are not correlating, then you might want to try to investigate to see what's going on. Okay, and then backup testing. So confirmatory tests are defined as tests that use different methodologies or reagents to detect the same substances as detected by the reagent strips with the same or greater sensitivity or specificity. So they make liquid and tablet backup tests available for some reactions if you are getting what you think are questionable results on the reagent strip. Maybe you've got a very highly pigmented specimen and you're not sure about the results that you're getting on the reagent strip. So these confirmatory tests will have their own positive and negative controls that would be performed either once per 24 hours or whenever the tests are required. So that would be dependent on your lab when they want to perform those controls for the backup tests. Some examples of common backup or confirmatory tests are clinitest for galactose, acetest for ketones, which are a byproduct of fat metabolism, which are usually completely broken down. So this used as energy when the normal source of energy, which is your carbohydrates, is not available. The ictotest is a confirmatory test for bilirubin, which can be an indication of liver disease. And then sulfoxylic acid, or SSA, is a backup test for protein. So based on your lab's protocol, a lot of times if any of the reagent strip results are positive, you may have to perform one of those confirmatory or backup tests also. Okay, here's a picture of the Clinitest, and we're going to go into a little bit more detail on each one of those backup tests once we get to the test on the reagent strip that they are used as a confirmation for. And there's also there's a couple of videos in Moodle that show how those backup tests are performed, so make sure that you take a look at those. And that's the end of this little introductory lecture 1. The next 2 lectures will be getting into the actual tests on the chemical reagent strip.